2904. So we are starting with the new chapter now. Wave motion is done. Please, there are many homework questions that I have given in the sheet. Try to attempt all of them. Only in one of the questions, in the second last question, will you find a need of a diagram. So please ask me when you come to that. Okay? For now, we'll start with superposition of waves. So you remember that when we were discussing vectors, we gave all the description of what is a vector and everything else, and then we came to the algebra of vectors, no? Trying to understand how, given two vectors, how do they add, how do they subtract, all those things. Then what we have discussed everything about waves. Then given at a point, let's say two waves meet, then what happens? How will they add, how will they subtract, and all those things? We'll try to answer that here in superposition. And this first topic is the principle of superposition. And before giving you the statement, let me talk about the sense of what we are doing. Let's say we have one wave, and how is the wave defined, by the way? By some value y. Na? If I specify a y, then you have a wave. Yes? So let's say I have one wave, then what is the job of this wave? You have these particles here. What is this wave? This is just a disturbance in the medium, right? So what will it do? The particles will start oscillating like this. If I consider a transverse wave, you can imagine as if the particles were basically sitting at their mean position, and what did this wave do? It thrusted them particles upwards, so that the particles have displaced from here to some other positions. Yes? Yes or no? Let's say I have one more wave, another wave, which is at the same position. They are both meeting at some point, and what is this wave doing? It's doing the same exact job to the same particle. Let's consider this particle, and this is given by some y wave. Then what is this wave doing? This wave is pushing the particle upwards. Yes or no? From its mean position. What about this wave? It's doing the same job. So what will be the net resultant effect? It's as if both of them are pushing the particles upwards, no? And their effects will add. What do you think? It's like you are pushing, two people are pushing in the same direction, then the forces add vectorially. Then what should be the resultant effect? What do you think it should be? Should be a little bigger wave? Something like this? Don't you think this is correct? The results add. You can think of in this fashion as well, that the particles are being pushed downwards and their results add. And you are pushed even downwards. Yes. So this was one way. And now what if we have a situation like this? What if I have a situation like this? Y2. This is my Y2 now. And now my Y2 is doing what here to this particle? What is it doing? It's pushing the particle down. But there is another effect which is pushing it up. So what should be the net resultant effect? Should I add the two? Subtract. And what if the effects are exactly same in magnitude? Then what will the case be? So you will have zero displacement. What will the wave look like? There is no wave. Do you understand? So when two waves meet at a point, then what does happen? This is the principle of superposition. It says that the displacement, these y's represents the displacement, no? Yes? These displacements adds vectorially. Vectorial. Why do I say vectorially? Because the directions matter, no? Directions matter. So let me write the whole statement. Did you get the understanding of what is happening? So let me write the statement. Achha, when two waves meet at a point, then we say that they superimpose. We will use this word. When two waves meet at a point, basically superimpose, then the resultant then the resultant wave displacement is given by the vector addition of the initial two waves displacement. This is not the exact verbatim statement from the principle. There is a 4-5 line statement in your books. You should have to remember that for your IB exams. But the crux is this. Then the resultant is given by the vector addition of the initial displacements. Okay? Then how should I write it? What will be the resultant? So if the initial was y1 vector and the other was y2 vector, then what should I write? The yr is given as y1 vector plus y2 vector.
So in the example that we just considered, the two waves, they are not meeting at any point.
No, you can imagine as if, so maybe you have some source S1 here, some source S2 here, which you have two sources of the waves, and now this will give off one of the wave like this, and the other will give off one of the wave like this, and they are meeting at some point B. And then what will be the net effect at that point? That we have written. Okay? Can you imagine now? Great. So they meet at this point B. Acha, from now and then I will drop the vector sign, but you should remember that direction matters. Okay? So even if I drop the vector sign right now, then the equation should be yr is equal to y1 plus y2. Acha, is the superposition principle only valid for two waves?
No.
Obviously not. You can have n waves. For n waves, how will you write? The yr can be written as summation I from 1 to n yi. Everyone knows this symbol. Acha, when the displacement add, then they add at all points. No? Please understand this. They are not adding only for one particle. If I have a wave like this, and I have another wave which is like this. Now tell me, where should the displacements add and where should it subtract? Can you see this? यहाँ पर up है, यहाँ पर down है. What will happen? Subtract. यहाँ पर up है, यहाँ पर भी up है. What will happen? Add. यहाँ पर down है, यहाँ पर up है. यहाँ पर down है, यहाँ down है. Add. So they keep on adding, subtracting at all points. When I write this equation, you should understand at every point this is happening. Do you understand? Is there any problem here? Good. So this is the principle of superposition. So is it written up till here? If the two waves actually meet at some point, then what should the final wave equation look like? Let's talk about that. Achha, before even that, I have to talk about some terminologies. So we will come across them more often than not, and these are called coherent and incoherent sources. And the first one is called coherent source. When are two sources said to be coherent? When you have two sources and they give off some waves, and let's say the phase difference between these two waves is a constant. It's a constant of time, it's a constant of space. It does not depend on time or space. Then it is called a coherent source. What if two sources are there and you have one of the source which gives off waves whose phase keeps on changing with time? That will be a very complicated scenario. We are not considering those things right now. That's called an incoherent source whose phase keeps on changing with time. What can be an example of that? The temporal phase, do you remember? The delta phi ds, 2 pi y capital T small t, that depends on time now. Depends on time, between two waves even. So what is the definition of a coherent source? Two sources, so please write with me, are said to be coherent if the phase difference between the waves emitted. If the two waves from the sources, from the respective sources, two sources are said to be coherent if the two waves coming from each source, coming from respective source, have constant phase difference. Have constant phase difference. Constant phase, not a function of space or time. Not a function of space or time. Remember this. Is it okay? And then what will be called an incoherent source? Where the phase difference is a function of space or time. Incoherent sources. Two sources are said to be incoherent if the phase difference between the waves y1 and y2, and y1 is coming from source 1, y2 is coming from source 2. Okay? Is dependent on space or time. Okay. Unless otherwise mentioned, we will always consider coherent sources. Is it okay? So most of our discussion will be on coherent sources, where our phase difference will be a constant of time. It will not keep on changing with x or t. Is it okay? If this statement is not so good, then please write a proper English statement. But do you understand? Though respective sources, one of the waves are coming from each source, and then the phase difference between them is a constant. Good. Can I go further? So let's talk about the resultant. So when two waves actually do meet at a point, their displacement add, but how will the final form of the wave look like? So we'll try to derive that. Resultant amplitude and intensity due to coherent sources. Let me ask you this one thing. Let's take y1 as a1 sine k1x minus omega 1t, and then y2 as a2 sine k2x minus omega 2t plus y, where this phi is given to be a constant. Let's say this is mentioned. And now let me ask you this. There are two sources which are giving these waves. Now, are these sources coherent or incoherent? Answer that.
Coherent.
So people are saying that these sources should be coherent. Anybody else with any other opinion? No? Let's see. What is the general definition of delta phi s, by the way? I gave you this definition that delta phi s was 2 pi by lambda delta x, but this was k x2 minus x1 basically. If you don't have the k same, then you can write k2 x2 minus k1 x1. This is more general actually. This is the delta phi s. Then let's write the delta phi s. This is k2. I think x's are same here. k2x minus k1x. Then you have k2 minus k1 into x. Is this phase difference 0? Obviously not. K1 and k2 are in general some different values. Then do you have a phase difference which is dependent on space? You do have that in this phase. What about delta phi t? What was that? That was omega 2t minus omega 1t. Actually, even that can be in general written as omega 2t2 minus omega 1t1. And this will be omega 2 minus omega 1 into t. Now, is this 0? Even that is not 0. So that means you have a phase which is dependent on space as well as on time. So is this are these coming from coherent sources? No. So when you have k1 and k2 to be different and omega 1 and omega 2 to be different, then you can't have a coherent source. That means these two are coming from incoherent sources. Just because the initial phase is a constant doesn't mean there is a coherent source. Does it make sense? So that means if I do want coherent sources, what should I take then? I should take this to be ये होना चाहिए. This is the correct formula. If I do really want coherent sources. So ये अब मैं erase कर रहा हूँ. Should I erase it or should I let it be?
Leave it, sir.
Okay. So that was, let me write it just to 2, 1, 2. Incoherent source. Incoherent. Coherent. Waves. Then if I want for waves coming from coherent sources, what should be the wave equations? Can somebody tell me that? Y1 should be, sir, the amplitude has nothing to do with the phase difference, sir. Yes? When I write in here, do I mention in A anywhere? So amplitude can be in general different. Kx minus omega t. What about y2? Sine kx minus omega t plus phi. Plus phi. These are my two waves which are coming from coherent sources. Let's say they meet at a point, and now I am talking about what will be the resultant. Okay? So when they do meet at a point, then what will be yr given as? What will be yr given as? y1 plus y2. That's just the superposition principle. No? Now please try to keep up. I will go into a very long derivation. So for people who have written it till here, please try to keep up. What is y1 given us? A1 sine kx minus omega t plus A2 sine kx minus omega t plus phi. This kx minus omega t looks to be like some theta. Then that looks to be like sine theta plus phi. What is sine theta plus phi formula?
Sin theta cos phi plus cos theta.
Yes, everyone knows the sin A plus B formula. Then what is this? Kx minus omega t plus A2 sin of kx minus omega t cos phi plus cos kx minus omega t sin phi. Now I think I will take some things common. A sin kx minus omega t के साथ what are the terms?
A1 and
A1 plus A2 cos phi. That's sin kx minus omega t plus A2 sin phi into cos kx minus omega t. Let me do some parameterization and I will assume some things. So I will assume that this thing, whatever, this thing can be taken as some AR cos theta or cos alpha, and this can be written as AR sin alpha. I I'm taking that right now. If I do take that, then what will be the result that we have? Let me take AR common and then what do you have? Cos alpha sine kx minus omega t plus sine alpha cos kx minus omega t. And now what does it look like again? Sin A plus B formula again. Then what should be the final form? YR is equal to AR sine of kx minus omega t plus alpha. This is my resultant wave. This is how my resultant wave looks like. But now I have to specify what is AR and alpha. Do you remember what was phi? Phi was the initial phase difference between y1 and y2. What is alpha? Alpha is the phase difference between y1 and yr. Yes or no? Alpha is the phase difference. See, kx minus omega t plus alpha, kx minus omega t. So it has a phase difference of alpha with respect to y1. What will be the phase difference with respect to y2? Phi minus alpha. I will look at it. We will do that. So, but how to find this AR and how to find alpha? I already have these equations. Now let's try to use them. So AR cos alpha कितना था? A1 plus A2 cos phi and AR sin alpha कितना था? A2 sin phi. Let's call it equation number 1, equation number 2. If I want AR, then how should I get AR? Square and add. Square and add, then this cos square plus sin square will become 1.
Yeah.
Can I take AR square common? You understand? I am doing this. I think I will get in the RHS AR square. Should I do this steps or is it okay with you? What will I get here? A plus B the whole square. A1 square plus A2 square cos square phi plus 2A1 A2 cos phi plus what about this square? A2 square sin square phi. Now look at this. A2 square cos square phi, A2 square sin square phi. I can take A2 square common, that will become sin square phi plus cos square phi. Again one. Then what do you get at the end? You get AR as under root of A1 square plus A2 square plus 2A1 A2 cos square. Have you seen this result somewhere?
Parallelogram result.
This is called a parallelogram law of two vectors, A1 vector and A2 vector, and the resultant ka amplitude is given like this. What is that phi? That's the angle between A1 and A2 vector. Is it okay?
I didn't understand how you took A1 plus A2 cos phi as AR cos alpha.
I'm assuming that. If I do assume that, then these are the things that I'm finding. And then I can find the AR ka expression. I can find AR by this formula. How will I find alpha by looking at these two equations? If I want to eliminate AR, divide kar lo na. If I divide the two equations, what will I get? 2 divided by 1. 2 divided by 1 gives you what? Tan alpha is equal to A2 sin phi over A1 plus A2 cos phi. Then what is alpha? Alpha should be tan inverse of A2 sin phi over A1 plus A2 cos phi. And if you do remember the things that we did in vectors, it's exactly the same as the things that we found in vector. It's exactly that. And if I make the diagram, then how will the diagram look like vectorially? This is A2 vector. This is A1 vector. And what is the angle between these two vectors? Phi. Then how should the resultant be? By parallelogram law? It should be the longer diagonal. No? Should represent the longer diagonal. That's the AR vector. And what is the angle between A1 vector and AR vector? What should be the angle? The angle?
Alpha.
This should be alpha. because angle is basically the phase difference between these two vectors. So this should be alpha. If this is alpha, then what is this angle? Phi minus. And that phi minus alpha represents a phase difference between the resultant wave and the second wave. Did you understand the whole discussion? You can find the final phase and the final amplitude by these two expressions. So from where do you want to write? Anybody wants to write from the start? एक बंदा है. देखो इधर से. Did you understand the derivation? Please make the diagram carefully. जल्दी जल्दी आ चलो. Please check my calculations, sir. What does that AR represent by width? That's the amplitude of the resultant wave. And what is the alpha? That's the phase difference between what and what? That's the YR and Y1 के बीच में phase difference. Please remember that. What will be the phase difference between Y2 and YR? Phi minus. You should remember these things. And please do remember that I have taken two waves which are moving in the same direction. I should point it out. Please write that point as well. Written up till here? Write this. If you are done this typing, how many days still writing? Okay then. Do you remember what was the expression of intensity that we found for a wave? What was the expression of intensity? You should remember the result. Don't look at it. V. S नहीं है कहीं पर भी. Good, very good. Then what is the intensity? What is the relation between intensity and amplitude? Intensity is directly proportional to amplitude square. Let me write this. So I am writing something and you will understand it later. This is for the classical result. Why am I highlighting this? It will make sense when we talk about modern physics. Okay, anyways. Intensity is proportional to amplitude square. Then what should be the intensity of the final wave, the resultant wave? Can you tell me the expression? What should be IR? Let me write it directly and then you try to think what it should be. Is it correct or not? Try to think that. Check if it is correct or not. Your intensity is proportional to amplitude square. Is there anybody who has a doubt in this? Or should I do it? करूँ मैं खुद से? बोलो एक चीज बोलो.
Do it.
अच्छे खुद से कुछ करना ही नहीं चाहते. जब सर पूछे ना कि मैं करूँ तो बोला कि नहीं सर हम करेंगे. What is this? IR. What is this? I1. Do you understand? And then what is the final result that you get?
So that A1 and A2 are not in the root
And
side.
there should not be any root areas. I think this is good. Is it okay? I wrote a root in all the other classes. Now I have to rectify that. अच्छा है मैंने ऐसे करके देख लिया. Is it okay? If you would have checked yourself, then you could have pointed out yourself. No. Everything spoon fed. Here comes. Okay. Is it done? Then let's talk about some special cases if it is done. I have done the derivation in general in the sense that I have taken A1 and A2 to be non-equal. What if A1 and A2 are equal, then what happens? So the case one would be if A1 equal to A2 which is equal to some A0. What should be the expression of AR? Can somebody tell me that? What should be AR? So this is A0 square plus A0 square plus 2 A0 square cos phi. This will be 2 A0 square plus 2 A0 square cos phi. 2 A0 square common ले लो. 1 plus plus cos phi. But now, what is 1 plus cos phi equal to? What is 1 plus cos phi? कितना trigonometric पढ़ा है?
2 cos square
2
5
cos
by 2 minus
2 cos square?
5 by 2 minus
That's correct. Minus क्या बोला? कुछ minus नहीं. 2 cos square 5 by 2. This is called the half angle formula ना you half that. So ये 2 into 2 4 हो जाएगा तो उसका root लूँगा तो कितना हो जाएगा? 2. तो ये final expression बता सकते हो क्या आ रहा है यार?
2 a naught
not cos.
A naught cos. अगर ये a आ रहा है then now you have to check yourself कि IR should be 4 I naught cos square 5 by 2. ये check करना basically square करना है तो equation को और कुछ करना है नहीं. ठीक है? What should be alpha here? Can somebody tell me that? That's a naught sin phi divided by a naught plus a naught cos phi. But the a naught cancels and then what do you get?
1 plus
Sin phi by 1 plus cos phi. But what is 1 plus cos phi written as?
2 cos
square 5.
What can sin phi be written as?
2
Sin 5 by 2 cos 5.
Yes, that is also a half angle formula. So I think I will get something tan inverse of 2 sin phi by 2 cos phi by 2 divided by 2 cos square phi by 2. And then क्या cancel है? 2 गया, ये cos गया. Then sin phi by 2 by cos phi by 2. That's tan phi by 2. Tan inverse tan. So what will you get this? Alpha equal to tan inverse tan phi by 2. And then you will get something like phi by 2. So if you have the amplitudes to be equal, then you get the phase difference of final wave as half of the initial phase difference. Is there any problem here? Try to take a case where amplitudes are unequal, and if the phase difference is 0, then what is the final amplitude? A1 and A2 are unequal and phi equal to 0. What should be AR?
A1 plus A2 का whole square.
Yes, what it should be?
A1 plus A2 का whole square.
A1 plus A2 the whole square.
A1 plus A1 plus
हाँ,
A2 sir.
A1 plus A2. A1 plus A2 होगा ना? Because there is a root again. Should I do that case now? You have written up till here. Take the case of the phase difference, like if A1 is not equal to A2 and phi is equal to 0 radians, then what is AR? That's A1 square plus A2 square plus 2A1 A2 cos 0. But what is cos 0? That's 1. So you get A1 square plus A2 square plus 2A1 A2. What is that equal to?
A1 plus A2.
A1 plus A2 the whole square, take the root. In that we will get as A1 plus A2. Is it okay? This is the AR. Can somebody tell me what should be the alpha here?
0.
It should be 0 because alpha equal to tan inverse of A2 sin 0 divided by A1 plus A2 cos 0. But sin 0 is 0, so, and tan inverse 0 is also 0, na? So you will get 0 radians. Can you take the case of A1 not equal to A2 and phi equal to pi radians?
A1 minus A2.
Should be no. Write your name.
Root over A1 square plus A2 square.
No.
A1 minus A2
A1
square.
No. You're taking a1 minus a2 the whole square. You can equally say it's a2 minus a1 the whole square. Then in general, what should I write?
Mod of A1.
Mod of a1 minus a2. That should be the correct expression. So what will it be then? A1 minus A2. So third case, if A1 is not equal to A2 and pi is equal to pi radians, then what should be AR? That's A1 square plus A2 square plus 2A1 A2 cos pi. What is cos pi? That's minus 1. So you will write A1 square plus A2 square minus 2A1 A2. This can be written as A1 minus A2 the whole square or A2 minus A1 the whole square. So I should in general write what? I should write something like mod of A1 minus A2. This is here. Is it okay? In some textbook they also write something like this, that AR is equal to A1 and this sign. Do you know this meaning of this sign?
Almost equal. Approx.
This is not proportionality, similarity. This is called positive difference. Okay? Positive difference. Now what do you mean by positive difference? That 3 minus 4, 3 positive difference minus 4 is plus 1. Take the subtraction but take the positive side. That's a positive difference. Okay? It's basically the same as a modulus. Huh? What should be the alpha here?
Tan inverse A2 by A1 minus A2.
No. What should be the alpha here? Think carefully.
Zero.
It should be 0 because what is sine pi? That's 0. So alpha equal to tan inverse of a2 sine pi over a2 minus a1 minus a2 no? Plus a, yeah? Cos pi. And what is this equal to? क्या कर रहा हूँ? What is this equal to? This is also 0, so alpha is again 0 radius. Yes? Is it okay? What if you have a phase difference which is pi by 2? Then what happens? Pi by 2. Try to get the AR and alpha.
Root A1 square plus A2 square alpha is
It's very easy.
tan inverse A2 by A1.
Correct. Try to find for pi by 2. Alpha will be tan inverse A2 by A1. Yes. These cases are not that hard to do it yourself even in the middle of exam, but they will be useful to you later. Let me do it then. Case 4. If A1 not equal to A2 and phi equal to pi by 2 radians. Then what should be AR? A1 square plus A2 square plus 2A1 A2 cos pi by 2. But what is cos pi by 2 now?
0.
That's 0. So this term goes away and then you will have under root of A1 square plus A2 square plus AR. Is it okay? And what should be alpha then? Yes. Can you do it yourself?
Yes, sir.
Check yourself. This should be this. Now that we have done all the important cases, can you just by looking at the final forms of AR, can you tell me in which of the case will you find the maximum AR? A max. Where will you find AR max?
A1 is equal to A2.
Oh, all the three expressions that we found for AR. Where will you find AR max?
And 5 is 0 reading.
When phi is 0. So you get this expression which is the AR max? Yes? A1 plus A2 is greater than under root of A1 square plus A2 square. You know this. Okay, you can check by numbers. You can check if it is not right. ये होता है. What about A min? Where will the A min be? In what case will you find A min?
Case 1.
So fourth case.
In the
When A equal to pi by 2.
pi by 2 या pi?
Pi by 2.
A1 minus A2 is greater than under root of A1 square plus क्या है? B minus 4 क्या बड़ा है क्या under root of? तो फिर min कहाँ आ रहा है? Minimum pi radian at pi radian. So this is AR min. So when will you find the minimum amplitude of the resultant wave? When the phase difference between the two initial waves was pi. And this is what we found now. If you remember that at the start of the lecture I said you have two waves and one of them is like this, the other is like this. I told you this now. One of them is like this, the other is like this. And what will be the answer if the amplitudes are exactly same? It will be 0. So are you finding 0 amplitude if the A1 and A2 are exactly same?
Yes.
So that leads to the minimum amplitude, not this one. Do you understand? Copy till here and then tell me when you are done. I will wait 2 minutes for you to copy. Then let's continue. So, can I give some questions? तुम्हें बोलता है दो या ना तो चलेगा.
Yes.
क्या ये बोल रहे हैं? नहीं है. क्या कटा लिया क्या? So some questions or should I just go on with the theory? Which do you prefer? क्वेश्चन करना है बहुत सिंपल ही देंगे Obviously I will make a sheet of this as well so that I don't have to write things but अभी के लिए यही तो एकदम सिंपल है ये तो क्लास में का बच्चा भी करता है देखते हैं कैसे कर पाएंगे क्लास हो गया आए हो ना Try to do it.
Sir, here is root 3.
मैं एक मिनट रुक जाओ AR कितने का बता रहे हो
Root 3.
What about IR
Sir, 12 I not.
12 कैसे आएगा
Sorry. Root 3. 3 I not, sir.
3 है
Three
that's
है.
correct What are the values that you are getting?
Root 3 I 3 I
Do I
not.
have to do this problem?
No, sir.
It's all good now. That is for A part. What about for B part?
Okay. Sir, 6 I.
6? 6 pi. No. What is that 6 pi?
Oh, sir. Sir, 2 pi by 3.
Root 3 A naught. So root 3 A naught कौन सी का order? A part या B part? So A का.
Sir,
A naught.
2 pi by
Except A naught, that's correct.
2 pi by 3.
Nice. And 2 pi by 3 what? Phase difference.
Huh, sir. No, part difference.
Yes, phase difference is 2 pi by 3. They have a constant phase difference of 2 pi by 3.
Yeah, phase difference 2 pi by 3. Phase difference 2 pi by 3, sir.
Should I do the question then?
Sir, only three answers. Only three answers.
No, obviously there is a I as well. IR. AR निकाल दिया तो IR से निकालना बहुत सिंपल है. So, given that for A part, delta phi is given to be pi by 3 radians. So what is AR then? So if the phase difference if same amplitude तो फिर क्या होता है 2a0 cos pi by 2 है ना, डायरेक्ट है फॉर्मूला. Sorry, cos pi by 2 होता है. Let's call it pi. Then what it will be? 2a0 cos pi by 6. What is cos pi by 6? Cos 30. What is cos 30? 3 by 2. So you will get root 3a0. Huh? And intensity is directly proportional to amplitude square, so 3i0. I think this follows very easy. What about the B part? For the B part, you are given the phase difference as the path difference to be lambda by 3. Then
4 pi by 9.
this was 2 pi by lambda into delta x. Then you can write 2 pi by lambda by 3. And then what will you get? 2 pi by 3 radians. Then what should be AR? What should be AR? That's 2a0 cos 2 pi by 6 pi. So ये कितना हो जाएगा? Cos pi by 3. What is cos pi by 3?
1 by 2.
1 by 2. So you get a0. And then IR is also equal to I0. एक बहुत simple question था. I think everyone can do this if they try. How many of you got this answer? Plenty of people. Okay, we'll do some more problems later on using the sheet and actually doing some interesting questions later on. I just want to discuss one more topic before we end the lecture today. That's called interference. Very interesting topic. I will talk about this much more when we go to wave optics. But abhi ke liye, what is interference? Interference is again basically a superposition of two waves, but there are some conditions actually that I will write when we go to wave optics. One of the main conditions for interference to occur is that the sources should be coherent. This is a must condition. Sources should be coherent. This is a condition. And now you will think, what is the difference between superposition principle and interference? Interference is basically again addition of many waves. Superposition principle is again addition of many waves. But superposition principle does not care about whether your sources are coherent or incoherent. It's general. In general, y1 plus y2. What about interference? Interference is a phenomenon in which you are basically meeting 2-3 waves at a point and something happens. I will talk about what will happen later. But something happens, and when will it happen? Only when the sources are coherent. This is a must condition. Very important. Okay? If it does happen, then what happens? Let's say there are some points at which the waves have zero phase difference. If they have at some points, so that is called constructive interference actually. Constructive interference. And what is happening in constructive interference? Your waves add perfectly. Perfectly meaning what? What is the amplitude? Your waves add perfectly, that means A max you get. So the resultant is AR max plus A1 plus A2. When can this occur? When the phase difference is what? 0. It can even occur when the phase difference is 2 pi. What about 4 pi? Yes? So in general, when can this occur? 2 and pi. So this can occur when phase difference is 2 and pi. This n, does it has to be a positive integer? Not even natural.
No, not integrated.
Can even be negative number, because what is cos of minus theta?
Cos theta.
That's cos theta. So n can be 0 plus or minus 2, and plus or minus 1, plus or minus 2, and so on. So if you have 2 points or 2 waves, you have 2 waves, and these 2 waves are meeting at some point such that the phase difference is 2 and pi, then they will constructively interfere. What do you mean by constructively interfere? Their A will be A max, basically. Is it okay? What should be the intensity, by the way? Can somebody tell me the intensity? What will be IR? बता सकते हैं? I did not find the IR max, but can you go back to the relation and tell me what it should be?
Root over A1 plus A2.
Root over A1 plus A2?
No, A1 square plus A2 square.
Root I1 plus root I2.
Root I1 plus root I2 is correct. Should be something like this. This should be the IR max. Yes? See, we did not talk about constructive interference that much. I am basically saying 2 waves will come at a point, they will add, and when they will add in such a way that you have a maximum amplitude, then I am calling it constructive. What do you mean by interference? In depth we will understand in wave optics. Okay, we will go in depth. For now it's just addition of 2 waves such that the sources are coherent. Okay? There can be another case where the 2 waves are coming together, but the phase difference is pi. Then what happens? You add destructively. This is called destructive interference. Destructive interference. And what is the amplitude that you get then? Your AR becomes AR min. That's mod of A1 minus A2. And when will this occur? Can you tell me the phase pi in general?
Zero.
1 plus 1.
Yeah, should it be root I1 plus root I2 the whole square? Or root I1 plus root I2? The whole square, you know?
Why? So,
मैं इंटेंसिटी का भी एक्सप्रेशन एक बार चेक कर लेता हूँ.
so once could you explain why?
रुक जाओ. अरे नहीं, इंटेंसिटी का भी एक्सप्रेशन आई थिंक वी रोट इनकरेक्टली अगेन. let's check कर लेता हूँ. क्या लिखा था मैंने तो?
I1 plus I2 plus 2 root I1 plus I2.
हाँ ये सही लिखा है. What is the intensity expression? Yes, this is correct. So if the phase difference is 0, then you will get root I1 plus root I2 the whole square, no? Sahi. And what if the phase difference is this? What should be the phi by the way?
2n plus 1 pi.
2n plus 1 pi. You can even write it by m pi, na? नहीं 2m बोल देता हूँ plus 1 pi. Where should m should start from where to where? 0 to? So ये 0 1. Can it be negatives as well? Can you take a -1 case? -2 plus -1 minus pi. What will that give? Again same, na? So can I write in general plus or -1? What should be the IR min?
Root I1 minus root I2 also.
Root I1 minus root I2 the whole square. Is it okay with everyone?
Yes, sir.
These are the points at which the wave has a phase difference, these 2m plus 1 pi, and their amplitudes are subtracting. Yes? And if their amplitudes are exactly equal, then they will subtract exactly equally and 0 aega. And what will you get here? 2a0. A0 plus A0, that's 2a0. Here A0 minus A0, 0. So we're done with this as well. I should ask equally, if the phase difference is 2 and pi, then what should be the path difference? What should be the path difference? Very simple to find. Because delta phi is 2 pi by lambda delta x, then what? N lambda? Let's check. So delta phi equal to 2 pi by lambda delta x. And delta phi को मैं क्या लिख दूँ? 2n pi लिख दूँ. So you will get delta x to be
N lambda.
n lambda.
Yes, sir.
And can you try to visualize what is happening? So if you have one of the waves, and one of the waves is a little behind, maybe 1 lambda से पीछे, कितना से इधर है इधर? Still you will add constructively, na? See? I will add constructively. If I am 2 lambda behind or 2 lambda forward, I will still add constructively. Does it make sense? So, वो behind or forward वो plus or minus से matter करता है. So please understand this. This is called the path difference. I have written that. What will be the path difference here?
Lambda into 2m plus 1 by 2.
2m plus 1 into lambda by 2.
It should be
Lambda
2m plus 1
into
pi.
lambda.
It should be 2 pi by lambda delta x. So pi goes away, and then what is delta x?
2m
This
plus
lambda
by 2.
m plus half. Yes or no?
Yes, sir.
M plus half into lambda. Then can you try to imagine that if you have a wave which is starting from origin, one of the wave is either lagging by lambda by 2 or leading by lambda by 2. Can you try to visualize what is happening? कैसा हो रहा है? एक wave ऐसा है, another wave is lagging by lambda by 2. So that means ऐसा है. उसका आधा पार्ट इधर है. Then what will happen? Subtract होना चाहिए. Does it make sense?
Yes, sir.
That is what we found now. So when you have a phase difference of 2m plus 1 pi, you find that your amplitudes actually subtract. Or या फिर path difference ऐसा है, then they will subtract. And when they subtract, then such a interference is called destructive interference. And when they add, it's called constructive interference. I just want to highlight one more point, and then we will be done with the chapter. Today's lecture. What was IR max that we found? So some notes. Everyone has written up till here, no?
Yes, sir.
No. What was IR max? That's root I1 plus root I2 the whole square, na? What is upon IR min कितना है? I1 minus root I2 the whole square, na? Yes? Let's take root I2 common, then what will I get? Root I1 by I2 plus 1 over root I1 by I2 minus 1 the whole square. Is this correct? I just have to check on that. Yes, this is correct. What can that roots be written as? So, if intensity is proportional to amplitude square, that means I1 by I2 is equal to root
A1 by
A1 by A2 the whole square. That means A1 by A2 equal to root I1 by I2. Na? So I can write it as A1 by A2 plus 1 over A1 by A2 minus 1. And I can equally write it as A1 plus A2 by A1 minus A2 the whole square. Is it okay? Just a little simplification. Writing the whole thing in terms of amplitude.
Yes, sir.
What is A1 plus A2 by the way?
AR.
That's AR max. And although this result may seem trivial, but the in between formulas are worth having. Remembering IR max by IR min,
AR max by AR.
that will be AR max
By AR.
by AR min the whole square. Please remember all the in between results as well.
Direct proportionality we can do it right.
Okay, you can obviously do it.
So we can also do it the other way by taking I1 common, right? Root I1 common.
Obviously. So if it is done, then I am not teaching anything more today. You want some one question? Very simple question. Try to do this. Given I max by I min, that's basically IR max by IR min is equal to alpha. Find A max by A min equal to what? Then A1 by A2 equal to what? And I1 by I2 equal to what? Try to do this.
So first one will be alpha square.
Yes. Give me the other two. No, it won't be alpha square.
Root alpha.
Should be root alpha, yes.
Yeah, root alpha.
The other two, give me that.
Okay.
One plus
1 plus
root 2
root 2.
by root alpha minus 1.
No. What is A1 by A2? Can somebody tell me that? If you can give me that, then that will be the end of the lecture. You focused here?
Yes, sir. हाँ सर.
नहीं हुआ क्या?
Yes.
It's the root alpha plus 1 by root alpha minus
Yes.
A1 by A2
क्या है root alpha?
plus 1 divided by root alpha.
That's correct. Very good. Anybody else with A1 by A2? Got
So
it?
then what?
Plus 1 by
Alpha plus 1 by alpha minus 1, what did be I2?
Alpha plus 1 by alpha minus 1.
I1 by I2, sir.
No, not I1 by I2. That's it. No. You're missing something. Do it very carefully, don't do it in a hurry. Yes. क्या करें? Should I do it? ये बहुत simple ही है actually. What will be the answer of A? So I am not even investing much time into this. That's done. Now what is A max by A min? That's A1 plus A2 divided by A1 minus A2. That is root alpha. That means root alpha A1 minus root alpha A2, that's equal to A1 plus A2. And from here we will get the root alpha minus 1 A1 should be equal to root alpha plus 1 A2. And then A2 by A1
Root alpha
is,
plus 1.
no, A1 by A2 second.
A1 by A2, sir.
A1 by A2 and root alpha plus 1 by root alpha minus 1. So this is the B part. What should be the C part then? So I1 by I2 is just the square of this. And that you will get as root alpha plus 1 by root alpha minus 1 of the C. Yes. So that will be the end of the today's lecture. We will discuss more things in the next lecture. Yes, Bishop.